Hello friends, today we are going to learn about the forces of fluids. This comes under Standard 9 Chapter 1. This chapter will give you an idea regarding fluid force such as buoyant force and its factors, famous Archimedes principle, Pascal's law, flotation, density and relative density, capillarity, etc. So, let's start. Now, what is buoyancy? Buoyancy is an upward force, that is upthrust, exerted by a fluid that opposes the weight of an immersed object. In a column of fluid, pressure increases with the depth as a result of weight of the overlying fluid. Buoyancy is an object's ability to float in a fluid. This is caused by upthrust or a buoyant force acting on the object which is equal to the weight of the fluid it displaces, according to Archimedes principle. Maximum buoyancy is when equal volume of fluid is displaced as that of the object. Example, if the weight of a stone is 40 grams, it should displace the same amount of water. Then the fluid has maximum buoyancy. A body in water has two forces, upward force by water due to buoyancy and downward force by object due to gravity. Now we are going to see the factors influencing buoyancy. First one is density of fluids, that is directly proportional. The second point, volume of the body in water, that is also directly proportional. See an important point. Though two objects have same mass, the buoyant force acting on it may not be same due to their difference in volume. Now we are going to see an important principle, that is Archimedes principle. When an object is immersed partially or completely in a liquid, the buoyancy experienced by it will be equal to the weight of the liquid displaced by it. Now, let us see some applications. The floating of a big ship is based on the Archimedes principle. Second application, an iron nail sinks because it has more weight than the weight of water it displaces. In other words, the density of the iron nail is greater than the density of water. See the next one, that is flotation. A body floats in a liquid if the buoyancy acting on it is equal to or greater than the weight of the body. If the weight of the body is greater than buoyant force, the body sinks. Then the next point, law of flotation states that the weight of a floating body is equal to the weight of liquid displaced by it. Now let us see the applications of flotation. A ship floats on water because the volume of ship under the water is higher than the volume of iron and other materials used for the construction of ship. Hence, buoyancy is high, thus it floats. The next application, kerosene floats on water due to the less density of kerosene than water. Next one is, a piece of stone experiences a loss of weight within water because water exerts an upward buoyancy force on the stone. Our next application, an egg sinks in pure water and floats in salt water because the density of salt water is greater, therefore its buoyant force is greater, thus floats. Now let us see an instrument known as hydrometer. Hydrometer is used to measure relative density that works on the principles of Archimedes' law of flotation. As the density of liquid increases, the hydrometer sinks in that fluid. Next instrument is lactometer. It can be used to measure the quantity of water added to milk, that is work on the law of flotation. It has no unit because it is a ratio. Then note an important point, when two liquids are mixed, denser liquid goes down whereas lighter liquid floats. Density of water is considered in two cases. Take the first case, honey, glycerin, mercury, salt, sugar solutions are viscous, hence density is higher than water, where kerosene, petrol, diesel, ghee, coconut oil are less dense than water, so it floats in water. Now, viscous force or viscosity, it is the property of a liquid to initiate a force that tries to prevent the relative motion between the layers of the liquid. Liquid having high viscosity are called viscous liquids. Then the low viscosity liquids are called mobile liquids. Now we are going to see an important law, Pascal's law. It states that the pressure applied at any point of a liquid at rest in a closed system will be experienced equally at all parts of the liquid. Now let us see some applications of Pascal's law. First one is hydraulic brakes, hydraulic jack, hydraulic press, excavator and hydraulic pump. Now, note this formula. F1 by A1 is equal to F2 by A2 or F1 by F2 is equal to A1 by A2, where A is the area and F is the force or pressure applied. Next one is capillarity. It is the rise or depression of a liquid in a narrow tube against the gravitational force or the weight of the liquid. Next point, as the diameter of the tube decreases, capillarity increases. Next one, cohesive force. It is the force of attraction between molecules of the same type. Example, force between water molecules, force between glass molecules and force between mercury molecules. Next type of force is adhesive force. It is the force of attraction between molecules of the different types of substance. See the example. Force between water and glass molecules, that is, water molecules stick on the glass surface. Adhesive force between chalk and blackboard. Attraction between cotton molecules and water helps to make the cloth wet. See the next one. Capillary rise. It is the cohesive force between molecules at the surface of the liquid. The molecules near the walls of the vessel have adhesive force. If the adhesive force is greater than the cohesive force between liquid molecules, the liquid near the walls of the vessel rises up. Capillary rise increases with the decrease in the diameter of the tube. Next one is capillary depression. It is when the cohesive force is greater than the adhesive force. Example, mercury in a glass tube and mercury in a vessel. See the next one, surface tension. Here, drops of liquid always take a spherical shape due to surface tension. A blade can be placed safely on the surface of still water. It floats on the surface of water as long as the surface of water is still. Now, it's the time to summarize what we have learned in this chapter. First one is Pascal's law and its application. Next one is Archimedes law and its application. And third one is law of flotation and its application. And next one, surface tension along with its examples. Capillarity, and the last one is viscosity. Now, this is the time to evaluate what we have learned in this chapter. Here are some questions. You have to answer it. First question, which principle defines the buoyant force and state the principle? Second question, explain the principle behind hydraulic devices. Third question, fluid pressure is exerted in all directions. State an example for this. Here is the hint, that is spherical shape of water molecule. The last question is state the equation between force, pressure and area. Now friends, how was the travel through this chapter? Hope it was a nice one and you understood what was told. Wishing you best of luck. Bye for now till we meet in the next video.